Good morning, gentlemen. This is the next experiment that we are going to explain, which is the title of the experiment is speed of sound in air. So what we are going to do in this experiment is we are going to measure the speed of sound in air using the cylindrical tube closed at both ends. You can see there, this is the cylindrical tube that we are using, which is closed at both ends, which have a piston, or we call it a plunger. You can move this piston front and back, and also you can see the other device, which is the function generator. It can give a lot of different functions: sine wave, cosine wave, triangle wave, and the different type of functions can be created. And we are using a CRO, which is cathode ray oscilloscope. So how we are going to perform this experiment, and this is a formula which relates the speed of a sound wave, frequency, and the lambda, wavelength of the wave. And this is our experimental part. This is an experimental setup. It is very clearly drawn in the handouts. You can go through the procedure, and also you can go through the diagram. This table clearly gives what we have to do in this experiment, and we have given n is equal to 1, 2, 3, 4, 5, 6, 7, and we have given frequency f is equal to 1200 and f is equal to 1500. So f means the frequency. We have to give an input frequency for a given particular voltage. You can see here there are so many dials are there in this function generator, but we are not going to use everything. We have to use this one, and also we have to use the voltage. Suppose if you look here, if you adjust this one, it can change the frequency. So what we have done, initially we have put for 1200 hertz, which is 1.2 kilohertz, and also 1 voltage. You can see you can move the cursor by using this button, by moving front and back. If you put 0, there's no sound and also no signal. You can see there. When we give the input voltage, you can observe the sound input is going inside, and also through the CRO we are able to get the input signal what we are giving here. This is the input signal, sine wave, and we are getting the output signal here. So now first one is n is equal to 1. N is equal to 1 means the maximum resonance. How do we know the maximum resonance is happening? Two methods. One is by hearing, and also the other one is through this wave. So when we hear, it is very difficult to identify the maximum resonant frequency or the maximum sound. So what we have to do, we have to adjust the length of the plunger so that the sound waves traveling inside the tube will be get adjusted for the maximum frequency. You can see here. So while we adjust the plunger, have a look on the signal in the CRO. It is getting maximum, because the sound also you are able to, maybe the sound is not clear, but you can if you notice it well, you can hear the maximum sound is coming. See, after that the signal is coming down, or it is shrinking. The reason is the sound waves are getting smaller and also getting interference pattern. The resonance is not clear. So now I'm going back, I'm adjusting the piston again. At the same time have an eye on the CRO screen. So the place where we are getting the maximum sound, you put the plunger or stop the plunger over there. After that, identify the distance or find the distance from the 0 to up to this distance. Here it is showing 0, 1, 2, 3, 3.1. So for n is equal to 1, x equal to 3.1. For the one loop, the maximum displacement or the resonant frequency will be 4.1. After that, for the second one, for n is equal to 2, what we have to do, keep on pull the plunger. I'm just adjusting. At the same time, I have an eye on the screen. The screen, see, all the wave signals are getting smaller, and when the sound is getting diminished, after that it is keep on increasing, because the sound waves are getting collected, or the resonant frequency is observed. So you see, this is a maximum, then it is coming down. So what am I doing? I'm just fixing at the place where we are getting the maximum amplitude. See, that is our distance. This is for n is equal to 2. Hopefully it may be clear, or sometimes it may be blurred, doesn't matter. That's our data. For this one it is 15, 16, 17, 18.1. So for n is equal to 2, 18.1. Now keep on pull the plunger, and then again pull it. can get the maximum for n is equal to 3, and do for up to n is equal to 7. This is for the frequency f is equal to 1200. Now what we have to do, change the frequency. It is quite easy. This is for frequency, adjust the frequency 1.5. 1.5 means 1500, and repeat the experiment from the beginning. Put the plunger back to the original position and then just pull down, and then you will get the maximum displacement on the screen and fill the data over here. After that, as usual, draw a graph, plot a graph between x versus n, and use this formula, find the value of here what we are calculating, or the speed of sound in air. Speed of the sound in air. Let me confirm it. Yes, speed of sound in air value. Here, using this formula, calculate the value of speed of sound in air, and that is the end of this experiment. Thank you.